Well, good morning, everyone, or good afternoon, depending on your time zone, and thank you very much for joining. This is the Customer Success Learning Session on leveraging SNMP in OCI, both the old and the new. And Charles Fox, one of our longtime experts in the software industry, is going to lead us through that learning session. And with that, I'll turn it over to you, Charles.
Okay, thank you very much. Yeah, this was an interesting one. SNMP is something that anybody who's ever networked a computer has probably at least heard of, and it's certainly been around a while. I'll cover a little bit of the history of it in a minute, but I learned a lot putting this together. It was surprising that I thought I knew a lot about SNMP, and I realized that my knowledge really was not as good I would like. And I also discovered that documentation and how-to on some of these things is less than ideal at times. That being said, thanks all for attending. Hopefully, you'll get some good bits of knowledge out of this that'll help you leverage SNMP in conjunction with OCI product. I called the session the old and the new because there's two parts to this. There is OCI as a notification mechanism, and that's been around for a long time. But as of release 7.3, it's SNMP as a data source, and that's probably why most of you are here, I suspect. And we'll cover that in more detail. I'm going to kill my video at this point just because you've all been introduced to me, so you know I'm not a recording or something like that. And it just saves a little bandwidth to make things go a little smoother. So let me share my slide deck here, and let's get started. All right.
I can see your screen just perfectly.
Good. And let's go. All right. Okay. And we'll be making these slides available. Joy will get a copy of them after we're finished here. Come on. Okay. Short introduction to SNMP. Just a little bit, just so everybody's on a baseline of understanding of what's there. SNMP, Simple Network Management Protocol. This is a little bit of the history of it. It's originally, came out many years ago. That's one of the more interesting things about the protocol, is its longevity, if nothing else. In the 90s, I was actually one of the lucky guys who got to work on the parallel protocol to SNMP, which was called CMOT. And that was for the OSI networking stack that was going to take over the world. I was at the DoD and was pushing OSI as the answer to networking, and that TCP/IP thing would just go away with the much more robust OSI standard. I ended up wasting about 5 years of my life on that because it never really went anywhere. But as you could see, the SNMP protocol went through a series of evaluations from the government and various standards bodies, and was really released in '91. The amazing thing about that is just how old this really is, and how it's had staying power despite how much it's changed over the years. Okay, so SNMP, it's been there. It's a grand old man of network management. But why do we want to leverage this in OCI? Well, because it's used everywhere, and there really isn't any other standard that seems to supersede it. And by that, I mean even your simplest, well, not every device, but almost your simplest devices have some sort of SNMP stack built into them. Most management products, your SolarWinds, your OpenViews, your OCIs, whatever, support it in one form or another. You guys requested that we support it. And the big thing is it fills a gap where we don't have a data source for a particular system, and it's not available, and at least it gives you some means to collect data on these systems. There are other options too. I'll talk briefly about some of the other ways you can do this. SNMP may not be perfect in all cases. Remember, there's collectd, which we support as a means of getting host data from Linux systems. That's a little easier to use, I think, than the SNMP integration. And also the REST API for custom roll your own stuff. Okay. Basic parts of SNMP. You've got a network element. That's the device that has the SNMP agent on it. That's the thing you want to measure. You have some sort of target network management station. There's the MIBs, which are used to decode the information going between these various agents, and I'll talk about those in considerable detail in a while. And SNMP is bidirectional. It can set data on devices. In our case, we're not really going to be looking at doing a lot of setting of device parameters. We're going to be looking at polling them and pulling back the various parameters that are exposed by the SNMP protocol. So pretty simple. The devil is in the details. It looks simple, but there's a lot of very subtle nuances to this that you will discover as we go through this that you have to get right for this to work properly. Okay, so I mentioned MIBs. That's what I like to call the decoder ring of SNMP. It means management information base, and it is essentially a listing of all the trees or listings of OIDs or object identifiers. Those are the actual elements that provide distinct values. And the MIB is used to take the data stream that comes back from SNMP specific to a particular type of device, and it defines how these objects are encoded and things like that. It also defines how to decode it and read that correctly. Now, MIBs are typically available from the manufacturer. If you buy a switch or a router, that sort of thing, except for the very, very low-end stuff that doesn't maybe have an SNMP stack, you will find that the manufacturer will provide these guys. They can be a little difficult to hunt down, but that's typically where you're going to go for these. Now, they're not for the faint of heart in that they, especially in conjunction with OCI, they do require relatively exact formatting to perform properly. And in general, the industry hasn't done a great job. There's a lot of variations in the quality of MIB files from manufacturers. And if you get heavy into this in OCI, you're going to discover that some of the ones that are sent out by the manufacturers that claim to be accurate or conformant to the standards really aren't. And they'll have to be tweaked. And that can be a difficult process. Now, what I've got up here is just an example of the MIB that we provide for reading data that comes from the OCI server. It's probably a little hard to see on your screen, but MIB files are loaded into whatever management tool that is receiving the alerts and used to parse these things up. On this screen, I've loaded the OCI one, and you can see that this area is the enterprise entry for, interestingly enough, it says Onaro, which is the company that originally built the first version of OCI. And that's still in there as the registered author of it. But, this defines the specific things within that MIB that are pulled back when OCI sends a message to a management screen. The green text is an example of what one of these things looks like. And needless to say, they're human readable, but they're not, it's not super obvious. As a completely side note, the screen you're looking at here is a product. It's not a NetApp product. It's called Power SNMP. And I used it as a test tool. You can download a trial of it. It's not an endorsement. There are other things that you can use to do the same thing. I just found it to be a nice little tool to use as a target for my SNMP gets and puts because I didn't want to do it against a production system, right? And this allowed me to just fire one up on my Windows 10 environment. So it's made by a company called Dart Communications. Anyways, again, not a NetApp endorsement of that, but if you need something to play around with to get this working, you might want to take a look at that. Now, SNMP and OCI, two different flavors. First of all is an alerting mechanism. That is, one of the things that OCI does, and does well, is notes violations of performance requirements, things like paths to storage not being inappropriate or not working correctly and things like that, and it generates alerts. And these alerts are typically kept within OCI, but a lot of times people want to have these alerts forwarded onto more overarching management tools. And this can be accomplished via SNMP. So that's the first thing we're going to talk about is enabling SNMP as an alerting mechanism. The second, which is probably what most people are interested in, is SNMP as a data source. That is the ability to collect data from an SNMP-enabled device. This came in version 7.3 and up, and is certainly available in the current GA versions that you can use. But if you're still running on a version prior to 7.3, you won't have this option. Okay, let's talk about the alerting service. You say, okay, I like my warnings out of OCI. I like my critical notifications out of OCI, but I want to plug this into my broader management scheme. I don't know, maybe a SolarWinds or something like that. But anyways, so what do you need to do to make this work? Gather up some environmental data. First thing you're going to need is where is your SNMP management console target server, or at least the proxy that sits between that and the management console. Sometimes those are required due to networking reasons. But you need the IP address of that server or proxy, and you need to know what port it's listening on. Standard is TCP 162. People do change that. Strangely enough, I've seen a couple people reference that changing the TCP port for security reasons because the security in SNMP is not particularly robust, and they don't like people polling their devices at will. But odds are you're going to have TCP 162 as your port. Then there's a thing called a community name. In the early days of SNMP, community names were kind of like almost like a user ID. They identified a group of systems that were supposedly reporting into the SNMP management server, and the security was weak, to say the least. It's all transmitted in clear text, and just simply by having the at least in version 1, by having a community name, you could interact with the service. The default on almost every piece of networking equipment that comes out of the box is what they refer to as the public name. And many people just leave it at that and use that. But you need to know the community name you want the trap to go to. You also have to go and define policies. You've got to have triggers for it to send an SNMP alert. So that's the other thing you want to do in your OCI environment is to determine what policies and that you're going to have violations triggered on. Now, I pointed out a little earlier that little tree in the Power SNMP viewer. There is a MIB that has to be loaded on that to make those things show up. That MIB is in the installation directory of your OCI server under Sandscreen, back to an Onaro reference, right? That's what it was called originally, /mib/sandscreen.mib. This is the file you want to take and you want to give to your SNMP administrator, and they will load that. Some people say compile, but you're really just loading it into their tools to properly decode messages that come from the OCI server. Okay, let's go over to our demo machine and we'll take a look. At where these things go, just to give you a feel for how you'd actually implement this. Okay. Very good. All right. Let's start out under the Admin tab and take a look at notifications. These are the various methods that OCI can communicate alerts. There's an email. That's pretty common. In fact, almost everybody implements that. You can use the write things to syslog, but the one we're interested in today is SNMP. It's the last one on the list. So if we were to add a target for messages to be sent, this is where we put in that information I told you to collect earlier. The IP address, the port number, and the community string, which is used to route the messages more accurately than just public, but public is often what you use. So we'd enter them at this point, and that would create a trap destination. Now, I don't own this demo server, so I'm not going to actually save this stuff. Mark C. would have my head if I went in and mucked up his system. But this is where you'd add it. Once that information was in, the second thing that you want to configure is let's see here. Come on, climb to the top of the screen, please. There we go. Events. You also have to go in and you have to turn on alerting. So we have windows here for both performance violations and Assure violations if you have the Assure module installed. And the one that we're interested in is SNMP. We can set it. You don't have a whole lot of granularity here, but warnings and above, or only to generate a message on a critical violation. And again, same down here, and make sure you save that when you're done. But if you have those turned on and you have your traps identified, you're pretty much in good shape to have at least the infrastructure going on that. Okay. Go back here. Now, Joy, I know I was supposed to poll you every once in a while and see, did we have any questions or anything that we need clarified?
Nope, we're all good so far.
Okay. So setting that up is pretty easy. And we'll move on to the tough one. This is a lot harder. This is SNMP as a data source. And when I first heard about this, early on before the product was even released with SNMP, we heard about it internally, and I was like, wow, this is the answer to all these devices that I don't have a NetApp defined data source listed in OCI. So this is going to be like this total savior, and I was quickly deflated somewhat, in the sense that a bunch of the engineers at us said, now, that's true on the basis of things that SNMP is sort of the ultimate data source, but that there was a lot of interesting limitations around it and things to be aware of that when I discussed this sort of thing, they said, please communicate these limitations and make sure that the people understand some of the things that are associated with this. If you compare this against a traditional data source, aka one from NetApp, the 3PAR or the NetApp collector, there's a bunch of things to consider. First of all, there is limitation on how much this thing can collect. I believe, if memory serves me correctly, you're limited to 26 objects, and even that can be dodgy, because within SNMP protocol, you can define returned objects as a series. So you might have 10 data points per second on a certain source, as well as a bunch of other things. What happens is you can run into excessive polling, particularly if you set the interval to very short order, that it generates just a lot of overhead, a lot of CPU usage, and you can get timeouts in the stack. And so if you're ingesting very, very large blocks of data, it might time out. The ways to get around that is to pull smaller blocks of things, or maybe increase the interval between polling. The SNMP stack talks through the OCI REST API. So does CollectD for that matter, and various other tools like ServiceNow integration, things like that. NetApp's really, really steering people for good reason to use the REST API for integration. It's neater, and but it is what the SNMP parser does. It takes part the SNMP message and then sends it to the REST API to file it onto the system. So you get the same functionality across both. You can see the data is visible in 7.3 plus dashboards. Something to remember that when using the REST API or SNMP, because once again, they're based on the same thing, this doesn't have anything to do with the OCI data that's modeled in the schema in the SQL store of the OCI server. So when you bring these things in, these objects, they're kind of standalone. And when you build a dashboard or something out of that, keep in mind that it's raw data. It's exactly what was reported by the device with possible some massaging by the MIB. The MIB actually can do certain mathematical operations and things like that on some of the data. But you're getting whatever it came back. There has been, we don't make any attempt to integrate it with other statistics to get a meaningful data point for you to install on the dashboard. So when you build the dashboard, you really do have to have a good understanding of what that data is and what it means, and how you want it presented in the context of that chart or graph or whatever it is you put up on the screen. And the other thing is that since this is coming in through the API, it's not available in the data warehouse. The SNMP data that you collect is not forwarded to the data warehouse. So that's something to be aware of. Okay. SNMP data sources, viewer discretion advised. I don't know how else to put it. It comes with some other challenges, and you won't see these in the sales glossy. But when you use this interface, you become the developer. And this is not to be taken lightly, in that since when you build an integration pack, which is a MIB and some other data, you're coding that up. And it's very difficult for the NetApp support guys to deal with that. It's just because they obviously have not been trained on it, and they probably would never have seen it before because it was assembled for a specific need on your part. The files to create the integration, and we'll go into some detail about how to actually do that, are, I say, complex in syntax, and there are people who would disagree with me on that it's JSON files and just the MIBs themselves, and that once you know what you're talking about, they're not really that difficult to figure out. But I say they're complex in that the parsers are very, very delicate when dealing with these. We had one test fail, drove the guys crazy trying to get it to work because there was one leading space in the first spot on the file, and that caused the parser to fail on it. So you can, very minor deviations from the way it's supposed to look can cause the entire pack not to work. And as I announced earlier, MIB files vary dramatically in quality from whom you get them from. Some of them, the manufacturers are very, very specific about making sure their syntax is right. Others, and we discovered this from a very, very large networking company who I won't point the finger at, but they had their MIBs were had all kinds of crazy mistakes in them that you wouldn't expect from somebody that big in the industry. So, be careful with these and realize that there's going to be some difficulty in testing these. Plus, when there is a failure, you don't get a whole lot of diagnostic information to point out what caused the failure. And so there's a lot of looking at the code and sort of trial and error correction of this. Now, this is a plug, admittedly, for NetApp engineering. It's more a NetApp engineered data source, right? An official one that comes in the data source packs is more than just a simple parser. There is a lot of effort that goes into building one of those things, and a lot of it is hundreds of man-hours of data analysis and normalization work. And what I mean by that is when we build a data source, we look at the device, we determine what's the best way to get information from it. Maybe it's a CLI, maybe it's an API, who knows. We look at that data, we go back and we figure out how to normalize that, because what you'll discover is when you use SNMP and you get raw data back from a data source, some things are listed in ticks for VMware, some are listed in data points per second, and there's no normalization between the two, which means you can put the data on your dashboard, but it probably doesn't make a whole lot of sense unless you've figured out the interaction between these two and how to normalize the data, that is, make sure everything is in bytes per second as opposed to megabits per second or whatever. That's where a lot of the work of a data source goes into, and that's all on you now. So realize that there's more to it than just getting the MIBs in and then saying, okay, I'm going to start collecting data. We maintain these things. If you build your own, you've got to maintain it as well. And the SNMP MIBs and things will change on devices from time to time as they get new releases. So that's our warning, is you are about to enter the developer zone, and consequently you're responsible for the quality of the results. Now,
hey, Charles.
Yes.
We did have one question.
Yes.
P. Gonzalez was asking regarding the REST API. Are we still at version 1.0, and does NetApp have a module we can load into PowerShell?
We're not. I believe on 7.3. I think we went at least a point release up. I think we're 1.1 now. I know that it was extended over the original one. And as for the PowerShell modules, that one I don't know the answer off the top of my head. There is a PowerShell component because I've had the SEs and stuff use it on occasion. I don't know if that's been updated over the version 1 though. We could certainly find that out. So let's keep that question, keep track of that question, and then I'll see if I can get an answer to it later.
Yeah, we'll follow up afterwards. Thank you for the question.
Yes. This is just kind of just sort of a stock diagram that they have. So what happens? We pull using the SNMP stack. We run that through an integration pack, which is the MIB mapping, and the JSON payload. The JSON payload is what takes the MIB entries and makes them understandable to the NetApp API. It takes that data and it submits it to the integration API. So that's basically how it works. Now, you heard I've used the term integration pack a couple of times. These are the 5 steps that are going to be required for you to get the integration pack, get it installed on the machine, and enter it as a data source. The first thing is this integration.json file. This guy is the mapping to get the MIB objects installed into the OCI environment as OCI objects, where they can then be used to put on graphs and things of that nature. This is a screenshot of it, what it looks like. The only decent instructions on how to construct this that I was able to find, I haven't been able to find anything more detailed than the good old NetApp documentation online, there is a section on SNMP, and this appears to be the definitive instructions for how to create this JSON file that does the mapping. Now, it's not super obvious and not super detailed. So this, if it's anything's going to bite you, it's probably going to be here in making sure that all of these things match up appropriately. And these are the definitive instructions on how to do it. I will hunt around for some better instructions. I did go search the corporate network at NetApp, and I just couldn't find anything that was more up to date than this. So this is how you will construct that translation file. Now, let's go back to our presentation here. The next step is to collect all the MIBs associated with the device that you want to look at. Now, notice there's multiple of them. A MIB isn't just a single object. A device like a network switch may have several MIBs associated with it. There's a bunch of standard ones, the so-called RFC MIBs that have basic stuff in it like, host name, CPU utilization, memory utilization, things like that. And very often what you'll see is a manufacturer will provide a bunch of these generic ones to pick up most of the data, and then they will have a custom one or two specific to their device. Well, if any one of the objects in any one of these MIBs is referenced by any other MIB, they're additive, right? You have to include that MIB as well. And I hope I'm explaining this well, but if you were to just include a MIB for, say, a Cisco switch that had Cisco-specific data in it, it might have in it a reference back to one of the like RFC 1212, which is just generic data that you probably get from any host, right? Well, you have to include that too. And what can drive you crazy is that the manufacturers don't necessarily make people aware of this. So you go, you build this thing, you run it, it fails because it says there's an object in there that's referenced that it doesn't have a MIB for that it can find out its translation parameters. So you got to collect every one of them that's referenced, and you have to build this directory structure, which you see here. And that is it's a zip file, and it does contain the directory structure you see there. It has to have an integration.json file in the root of the folder, then it has to have a resources folder, and under that it's got a MIBs folder, and then that contains all the MIBs themselves. And it's got to be in this format, and it's got to match exactly. And then you package all this up and load it into OCI, and we'll show you actually how to do that. I'll do screenshots, and then we'll go and take a look at it live. Once that's done, then you can go and create an integration data source. So this is, again, that's another view of the packaging, but as you can see, there is a very definite structure to this, and the JSON file, again, has to match to all the components that you want to monitor there, and it has to be in very specific format as well. And between these two things, these are what make up the quote integration pack. Okay, it's a zip file. Remember that. Zip it. I think it's interesting that they chose to use zip format, which I think was really done to preserve the directory structure, so that it was just easy to upload as a single file. That's the link to the documentation page I brought out earlier, the definitive guide to how to build one of these. Here's how you set this guy up. Once the pack has been built, there is an SNMP integration tab under Setup. And basically, you click Select File. You're going to go out. You're going to pick that zip file, and you're going to hit Import. And it will read that in and make it available in the menus further on when you do your configuration. It says it will overwrite any conflicting package. So if you load something by the same name, It'll wipe out the other one, so just be aware of that. And then you now have the ability to go into the data sources and pick the SNMP component. It's under, the vendor is listed as integration, kind of like the same way CollectD is. That means it's using the REST API to get its job done. But so when you open it up, don't waste your time looking for SNMP. It's not that. You look under integration. When you do that, by default, the model will be SNMP. It's a little weird, vendor and model, but that's how they chose to integrate it to the system. And collect integration, and then you add this guy as a data source. Now, under configuration, this panel on the right, you're going to want to put the SNMP agent address. This is not the management console that we did in the first one. This is the actual target object that you want to measure, that you want to collect data off of. And lastly, if you've done the upload correctly, the integration pack that you named will show up in this field. And if you put those guys in, you should be good to go. A couple of things about this is a data source can be pointed against multiple IP addresses or host names. You can only have one integration package referenced in a data source, but you can have it looking at multiple devices. And this is it's just a nuance that it kind of works both ways. Is that you can also have one integration pack with multiple IP addresses, and you can also have it work the other way. What's it look like when you've done it straight? And we'll go in and look at this live. But the little hooked icons, the chained icons, are what the integration type is referenced by, and these will show up when you edit a widget. You'll have all your regular stuff up top. If you installed CollectD or some other things, you might see CollectD objects in there as well. They typically will fall at the end of the list, below all the standard things, and now you can take these guys and use them in the actual dashboards themselves. Now, a quick under the cover things. This is probably not really relevant to everybody, but I thought I'd throw it in. It was in the engineering decks. The SNMP data is stored in the Elastic database. It is not stored in MySQL. I mentioned that earlier. And when you define your integration type, all you're doing is defining an index in Elastic that refers to the data that's collected. And the interesting thing is going back to what I said earlier, you can have one data source of pointed at 10 addresses. You can have 10 integration sources pointed at one IP address. So it all comes down to basically one big long list of indexes in Elastic that you can pull up and reference the data from. Okay, let's take a look at a running system again, just to give you a feel what it looks like. All right. Let's start out by seeing the end results. We'll go to the end results first. Let's show all dashboards. Let's take a look at this bar chart, for instance. Come on. Open up. All right. That's live data being pulled off. I believe it's an Ubuntu Unix machine. Certainly the process tables and things would imply that. And one can go in, turn editing on, and pick one of these widgets. And here is our options. This machine's running CollectD and SNMP, which is why you're seeing. But notice they're all listed as a type of object as integration. But here is the SNMP values that are being brought back from that Ubuntu host. There's quite a few of them. Now, again, this is not my dashboard, so I don't want to modify it or Mark's going to kill me. But that is how this stuff is surfaced in the UI. And at that point, it's straightforward. You can use it any way you want. The data analysis options, the changing how some of the things are displayed in time periods, things like that, are supported just like they are on any other object. So that is an example of the end result. Let's take a look at defining a data source. These are all the ones that have been loaded into the system. Right now, we see we have one for Windows, we have one for Ubuntu as well. To add these, we'll go. Remember, the vendor is integration. Model is SNMP. And integration pack, we should see a couple under there, which we do. This is where your IP address, your target IP address goes. And like I said, you can have multiple IP addresses if you wish. Now, this is an interesting little sidebar. SNMP version. You see version 1, version 2, version 3. There's actually a version 4 in works. I don't think it's fully ratified yet, but V1 is the original one from 1991. Little nice thing about it is its security is essentially non-existent. It uses only the community string to identify the OCI system as a valid user. It's all transmitted in clear text. Good chance that your network people won't allow you to use V1 just for security reasons. But it is there and it is supported. And in some cases on very simplistic devices, that's all you're going to get. Now, if you pick V2, you've got the community string, but you also have an option of username and password that provides you a more secured connection. In the case of V3, you'll see that we not only add authentication, but we also add encryption and choice of encryption schemes, protocol types, etc. So there's options to do this more securely. You're probably going to want to go that route. So I think you're going to end up using version 2 or version 3. But it's a little dicey here in that you need to talk to your network admin people and make sure you know what ciphers they're using and that kind of thing to get this right. What else do we want to show you? I think that's pretty much all I've got. Let's go back to the slides. I had a few cleanup questions and things that I wanted to ask. All right. Okay. We're going to see if I can get this right here and do a poll on this. This is the little NetApp secret. I read through some of the early documentations and things, and they reference sample integration packs. Now, why would this be a good thing? Well, because they can be used to bring up a test system like the one I just showed you. But when I went and looked for these guys, I went out and looked on the publicly facing NetApp site, never found any of them. So I made some inquiries, and believe it or not, the people who wrote them are a little scared about releasing them, because if they do, and it goes out to a lot of you, the author, whoever wrote it, right, which is somebody internal to NetApp, is on the hook to support them and keep them up to date. And these things haven't been tested in depth, so I think they're a little fearful about handing out samples. Now, I write this up because when I did this, to even get as far as I did on the relatively simple use of SNMP, I really could have used some files that were guaranteed to work. I shouldn't say guaranteed, that were supposed to work, that were correct in syntax and all of that. And I'm pretty sure that most of you are going to feel the same way about that. If you just had a sample to work from as a template, doing your own custom modifications would be a lot easier. So if I were to suggest that there would be some unbranded, unsupported, not guaranteed for any fitness of use sample integration packs whose sole purpose was not to be used in production, but to give you a working sample so you can reverse engineer your own. I was going to try and see if I could get the engineering guys to release that and make it available to you. So what I'm going to do now is I'm going to stop my sharing, and I'm going to try this fancy poll thing out. So I'm going to open the poll and bring it in. And this is simple. Now, I've opened the poll. If you guys want a sample integration packs for a couple of standard devices, like a Windows server and an Ubuntu server, maybe a popular Cisco switch or something like that, let me know. Just ping the poll, and that way I can judge how many of you would be interested. Because if I say there's 30 people on this session, and 25 of them say, "Man, I'd really like to have that," it gives me more ammunition to put the screws to these guys to release some sample packs, which I really think would make life a lot easier. So I'll leave that poll open. If you're maybe, I haven't used this function very often, so maybe you're having trouble finding it in the UI. But hopefully you can work your way through it. That being said, that's officially all I've got. Joy, are there any other specific questions that I may or may not be able to answer that came in?
We do have one. Scott Hansen just wanted to know what type of devices this could be used for.
That's the beauty of it. If this thing has one benefit, it's the ubiquity of SNMP. I will give you an example of some of the things I played with. I instrumented a Windows 10 system. Microsoft doesn't like SNMP. They like Windows WMI. And it was actually kind of a bear to get SNMP turned on the Windows 10 system, but it was possible, and I did get it to work. So certainly hosts, a LeBaire power conditioner, right, to check the temperature and or of a LeBaire air conditioning system, or a power monitoring system that both LeBaire supplies that. They have SNMP interfaces. So you can see what the voltage is on the power supplies. Are you on standby power? Are you in backup? What the temperature in the data center is the air conditioning running, how many hours did it run in the last 24-hour period? You can get stuff like that from those devices. You can even use this interface to poll tiny little devices like Internet of Things. Some of those, you take a little Linux computer like an Onion or something, Onion IO, and you can actually instrument those guys to create your own sensors. But SNMP is mostly focused on networking equipment, so you'll see it available for just about any managed switch, router, or device of that nature. So that hopefully answers your question. And I got the people on who are still on. We're at least half have polled that they want the samples to be made available. So I'm going to take that as a endorsement that I should go on a quest to get those released out to the public. Okay. Anything else?
Sharon McCowan had a question. Is there an Exadata sample?
Not that I know of. There's only the ones that I saw that were teed up by the engineering guys as ones that they thought they could do were very simple. There were a couple of Cisco switches. I believe there was a fiber channel switch, Windows Server, Ubuntu, Red Hat, and I don't remember an exabyte. But so I think the answer to that, unfortunately, is no. Okay. Anything else?
We did have one compliment in the chat. So the session was very informative. Thank you for organizing it. We will soon be using the SNMP integration on OCI.
Excellent.
So,
well,
thanks for that.
Yes, and if whomever was kind enough for that, if you get into it and have some questions, I don't object to you contacting Joy and passing that request for information on to me, and I'll be happy to see if I can research it and get back to you. So don't let the unfortunate complexity of this prevent you from using it to its fullest extent. Okay. This has been a great learning experience for me. I really learned a lot on the internal workings of OCI and SNMP. I hope you find the experience the same. Thank you all very much for taking the time out in your day to listen to me ramble on about this rather technical subject. And everybody, have a nice day.
Thank you so much, Charles. And thank you for everyone for joining. Have a nice Thanksgiving. And we'll be with you again on our next learning session. Hope you can join us.